By definition, a parabola is the set of all points equidistant from a fixed point, called the focus, and a fixed line, called the directrix. And you know how we think about parabolas when we're thinking about graphs of quadratic equations. You don't really think about a focus and a directrix, but this is a real formal definition of what defines that shape. So I've got a couple of sketches here. We know from prior experience that quadratic equations can be parabolas that open upward or parabolas that open downward. And if we think about how this is defined, all of the parabolas that we're going to be looking at have a vertex at 0, 0. And the focus, if the focus is above the vertex, then that ordered pair would be 0, C. And the fixed line, the directrix, excuse me, that is not 0, C. I'm confused. It's 0, P. And the fixed line then would be y equals negative p. Now, if we pick some point on our parabola and call it point P and give it coordinates x, y, then if we measure the distance from P to F and the perpendicular distance from P down to the directrix. Okay, so that's a perpendicular distance, and that's going to intersect that line y equal negative p at some point L. The coordinates of L would be x, negative p, and then according to the definition of parabola, that distance from P to F has to exactly equal the distance from P to L. So we would put absolute value around that so we don't have to worry about what direction the distance is measured in, but the absolute value of PF has to equal the absolute value of the distance PL. Now the other option, of course, is that our parabola would open downward, in which case the vertex is still at the origin. P is still some real number, and the coordinates of the focus in this case would be 0, negative p. The equation for the directrix would be y equal positive p. So for a parabola that opens upward or downward, the equation will always be, and this is a little bit different than what you're used to seeing, the equation will be x squared equals 4p times y. So the coefficient of the y term is going to help you figure out what exactly is the value of p. Now, looking at that equation, know that if the p value that you get in this equation is greater than 0, then you've got a parabola that opens up. If p is less than 0, you've got a parabola that opens down. The focus will always be the point 0, P, and the directrix will be the line y equals the opposite of P. Now the other two possibilities for parabolas, if we simply are thinking about this definition of parabola and we're not restraining what we're allowed to consider to just functions, then you could have a parabola that opens to the right or opens to the left. Okay, if you've got a vertical directrix, the vertex is still at the origin. The focus then would have to be on the x-axis instead of the y-axis. The distance from the vertex to the focus is still p units. The distance from the vertex back to the directrix is still p units. So if our focus is on the positive x-axis, then the coordinates for it would be p0. The equation then for the directrix would be x equals the opposite of p. And then if you've got a parabola that opens back to the left, the coordinates for the focus would be negative p0. And the equation for the directrix would be x equals p. So in both of these cases, the equation would be y squared equals 4p times x. And again, if p is greater than 0, you would have a parabola that opens to the right. If p is less than 0, your parabola opens to the left. The focus then would have coordinates p0, and the directrix okay, let me try that again. Directrix would have the equation x equals the opposite of p. So it's a different way of looking at parabolas. Alright, say we've got the equation y squared equals 20x. That fits the basic form of y squared equals 4px. So I know this is a parabola that either opens to the left or to the right, and which way it goes is going to depend on the value of p. 20 equal 4p. So it's easy to find the value of p is 5, so that tells us that our parabola is going to open to the right. Oops, that's not what I wanted. So if I'm going to sketch this, what I know at this point is the vertex of our parabola would be at the origin. If the parabola opens to the right, then the focus is out here, and the coordinates for that point would be 5, 0. The directrix would be a vertical line back here somewhere, and the equation for that line would be x equals negative 5. And then we could sketch the curve. So you'd have a parabola is always going to curve away from the directrix, kind of thinking about curving it around the focus. Okay, and I'm going to cheat just a little bit to make this look good. Clone, flip. There we go. So that would be a reasonable sketch for that parabola. Another example. Suppose we're told that we have a parabola that's symmetric about the x-axis. And goes through the point 1, negative 4. Okay, now I'm going to think about where 1, negative 4 is. 1, negative 4 would have to be, somewhere about right there. And if that point's going to be on our parabola, and the parabola has a vertex at the origin, we've got to have a parabola that opens to the right. So our basic equation is going to be y squared equals 4p times x. We have an exact value for an x and an exact value for a y with our ordered pair here. So if we plug in negative 4 for y and 1 for x, then we can find the value of p and write the equation. Y squared would equal 16x. So if that's our equation, and we think about how this has to work, I know the focus has to be the point 4, 0, and the directrix has to be the line x equal -4. -4. There we go. Whoops. What just happened? Let's try to underline directrix and focus there.